Let's sketch a graph of f of x equals x minus 2 over x3 by taking the given steps. The first step is finding the domain of function. It's a fraction. Denominator of the fraction shouldn't be 0. That means x cannot be 0. X-intercept. Numerator equal to 0. X is 2. Therefore, 2 and 0 is x-intercept. Obviously, the function does not have any y-intercept because denominator is x and x cannot be 0. X equals 0 is vertical asymptote of the graph of the function, and y equals 0 is horizontal asymptote. In order to find the vertical asymptote of a function, you set the denominator to 0. In this case, x3 equals 0, meaning x is 0, meaning x equals 0 is vertical asymptote of the function. And in order to find the horizontal asymptote of a function, you compare the degree of numerator and denominator. In this case, the degree of denominator is 3. The degree of numerator is 1. The degree of denominator is more than the degree of numerator. Therefore, y equals 0 is the horizontal asymptote of the graph of the function. Next step is finding local extrema. In order to find local extrema, we draw the sign chart for the derivative. Derivative is 0 at x equals 3 and undefined at x equals 0. If you plug a random number into the derivative more than 3, let's say 4, you get a negative number. Between 0 and 3, I plug in 1. If you plug in 1, you get positive. Less than 0, we plug a negative number, let's say negative 2, we get positive again. So it's increasing, increasing, and decreasing. So this point, 3, and 1 over 27 is local maximum of the graph of the function. Point of inflections. In order to find any point of inflection, you have to do the same thing for second derivative. At 0 and 4, at 0 it is undefined, at 4 it is 0. More than 4, you get a positive number, negative and positive, by checking the number within the intervals. Concave up, concave down, and concave up. If you plug in 4 into the original function, you get 1 over 32. That means you have 1 point of inflection. Put all information together and sketch the graph of the function. Y equals 0 is horizontal asymptote, and x equals 0 is vertical asymptote. 1, 2, 2 and 0, 3 and 1 over 27, and 4 and 1 over 32. Less than 0, the function is increasing and concave up. Starts close to the asymptote, get close to the other asymptote. Then at 2 it is 0, gets to the maximum, concavity changes, and it's getting closer and closer to the horizontal asymptote. So you have a local maximum at this point and point of inflection at this point. That's it.